I'll be the first presenter of the Programming with C++ for Beginners. So make sure you're in the correct workshop. This is the Programming with C++ for Beginners. So we'll begin shortly in a few minutes. There's something I need our team needs to set up first. We'll send a link for a Google form, which we'd like you to fill. Okay, so our team has already sent the link in the Zoom chat, so please fill that first. Yeah, so we'll start in a few minutes. Can you guys also go to this second link, codecollab.io, and please sign up over there. So if you see in the form, there's actually a Code Collab link. So you need to sign up to codecollab.io first in order to send that link. Okay, guys, we're going to begin our presentation now. So, okay, so welcome to Programming with C++ for Beginners. I hope you guys have had your lunch. Since this will be a 3-hour workshop, so it's going to be quite long. So let's begin. So here's the guideline of what we're going to do today. So there's going to be 6 sections. I'm going to go through the first and second part, while my teammates will continue on the third, fourth, and fifth part. So in the first part, the why C++, we're going to introduce you to C++, and we're going to try to convince you on why you should learn it and why it's still useful in the future. And next, we're going to teach you how to run C++. So mainly today, we're going to teach you how to run it online on the Code Collab link we mentioned earlier. And for the third part is basic syntax, all the way until functions is the main part of this workshop, where you actually learn how or what the rules of C++ encoding is and how you can actually code it. So let's begin with the first part, why C++. So what makes C++ so different from other programming languages is mainly due to its speed. So C++ is one of the fastest programming languages in the world. So if we compare it to other programming languages, like popular programming language Python, which is known because of how easy to use it is, C++ is around 100 times faster than Python. So that's a lot. It makes a lot of difference. So although its syntax is a bit more complicated than Python, it's worth it because of its speed. Next, C++ is also a general purpose programming language. What does that mean is that it can be used in many different areas. So not just one specific area. So I'll give you examples in which areas it can be used on later. So the opposite of a general purpose programming language would be a domain-specific programming language. An example of that would be HTML, which stands for Hypertext Markup Language. So this language is used specifically for web development. So it codes the structure of the web page. So you can't use it for anything else, basically. But C++, you can use it in many different areas, which I will go through right now. So where is C++ used? So as I mentioned earlier, it's used in many areas. So the first one is used in operating systems. It's used to build part of Mac OS X. It's also used to build servers and databases. So for those of you who know MySQL is actually built using C++. So MySQL is one of the most important database management systems still used today. C++ is also used to make desktop applications, such as Adobe Photoshop, which is used to edit images. And I'm sure most of you know what Photoshop is. C++ is also used to make games. Call of Duty, Half-Life 2, Quake, they are all made in C++. C++ is also used in aircraft systems, such as the ones used in F-16 and F-35. And what can you, as a student, do with C++? So the most obvious way you can use it is for competition. So there's this term called competitive programming. So competitions that has this term, competitive programming, will usually tell you to write the code to solve a task within a time constraint. So the reason why C++ is popular in these types of competitions is because it's very fast, like I mentioned earlier, which is why it's able to pass the time constraints. So a few examples of these type of competitions. For the first one is NOI, which stands for National Olympiad of Informatics. So this is organized by NUS, and their recommended programming language is actually C++. So There's other programming language you can use like Python, but it's not recommended because C++ is the fastest. Next, there's also IOI, which stands for International Olympiad of Informatics, and Google Code Jam and Facebook Hacker Cup. So entering all of these competitions, and if you win even some medals or prizes, it can be very helpful for your portfolio, which can allow you to go to universities and get scholarships or even jobs in the future. Which brings to the next point. If you have a high proficiency of C++, there will be employers who will seek after your skills. So although C++ is probably not the most popular language nowadays, it's still highly sought after. So I'll go on to the next section, which is how you can run C++. So before I get into exactly the steps of how you're going to run C++ today, I want you to understand a few terms. So first of all, C++ is a compiled language. So what does that mean is that it needs a compiler to run it. So a compiler is a program that processes statements written in programming languages and turns them into machine languages. So these programming languages are human readable, meaning that only us as humans can read it. So the computers can't understand these words like if, else, those things. They can only understand ones and zeros. So compilers, they turn these programming languages into machine language, assembly language, so that these computers can actually run the program. So next, there's also IDE, which stands for Integrated Development Environment. So Integrated Development Environment is a software that helps you as a human to code. So these IDEs help you in different ways. For example, they have syntax highlighting, which is where they color some of the words to make your code easier to read. And they also have autocomplete and auto indentation, which saves your time and helps you code faster. So there's two recommended IDE if you want to run C++ offline. So if you want to run C++ offline, you need to download the compiler and the IDE. So our few recommended IDE is, the first one is Visual Studio Code. So Visual Studio Code is one of the most popular IDEs, not only for C++, but also other programming languages. And for C++, there's Genie, which is a really good IDE to code C++. But today we're not going to teach you how to download and run it offline. If you want to do that, I highly recommend you to search online. So we're going to try running C++ online on a website called codecollab.io. So I hope you guys have signed up for this Code Collab. Actually, I'll give you 1 minute to try signing up, either by Gmail. Okay, so I hope you guys have signed up for Code Collab. I'll continue on to the next part, which is what you should do. So once you sign up for Code Collab, you should see this webpage, which shows all projects. So for now, you shouldn't have any projects yet. So I want you to click on the plus button on the, the plus button on the right side. That will create a new project. So this should appear. Choose the language as C++ and name your project however you want. For me, I wrote C++ for newbies. Then click Create Project. So you should see the C++ for newbies project now in the web page. Then you should click the triple dot, which is the settings. So if you click that, this thing will appear. And I want you to click the share. So next, you should see this. And I want you to tick the link is enabled. So by default, this should be unticked. And I want you to tick it. I want you to also untick the view only. So both of this, the purpose of both of this is to allow anyone with the link to edit your code. So the reason why we want to do this is because we want to help you throughout the workshop, where we'll give you practices. And we can help you out when there's unexpected errors or there's something we want you to do. So I hope you guys have done this, and I want you to also fill the form if you haven't. And okay, so I think I'll give a 1 more minute. So make sure you guys have filled the form because that is very important, so that we can help you. Okay. Okay, so from the responses of the form, I see that not all of you understand. So once again, once you created a new project, I want you to click on the triple dot, and you should see this black box which says open, share, more info, and delete. So I want you to click share, and this should appear. I want you to click link is enabled, tick it, make sure to tick it, and also untick the view only. So this is so that we can edit your code in your code collab. So then you should click the X button, and we should be able to edit your code now if you have done these two things, and also fill in the form where you can send us the link of your code collab project.
Okay, so hello everyone. My name is Ling Song, and I'll be going through the basic syntaxes for C++. So this will be the base. This will be how you start writing your code, and how you can start going into slightly more advanced stuff later in the workshop. So make sure you listen to this very carefully because this is the base. This is the foundation of C++. And if you miss out one or two things, you may find yourself in a pickle later. All right. So before we can start out writing any lines of code, right, we must first prepare the compiler for us. So this is what we will write for the first line at the very top in your main document. So let me show. So this is you can click on here, click on the main.cpp, and here is where you will start writing your code. So this is your first line, right? Your first line, we will start off writing include bit/stdc.h. So what this means is that what includes means is that we are in a way trying to have the libraries that our program might need to run the code. So you can think of libraries like bookcases. And every time you include something, you are including one bookcase. So for today's workshop, we'll be including bit/stdc, which is like a very broad base include, where you include multiple bookcases or multiple types of code that we will need for today. So this is just a quick description of what include is. There's definitely a better explanation out there, but since we are beginners here, so this is like a quick way for you to visualize what it means. So that will be our first line of code. For our second line of code, we'll be using namespace std. So what this does is that it tells the compiler that we're using C++ standard library, which the standard library contains some of C++ most basic functions. And you'll notice that at the end of this statement, I have put a semicolon, right? Semicolons in C++ is very important, and I'll explain that in more detail in the next slide. But you for now you can just put this in, but know that without semicolons, your code will essentially break. So that will be for the first two lines. If you haven't finished copying this down, that's okay, because I'll be typing along with you guys later. So that is only for the first two lines here. Then the next few lines will be your actual code. So you guys can just take a quick glance at this for now. And instead, what I'll be doing is I'll be actually going through how to type it. So let's type it together. So we remember the starting will be include, this will be the first line where we will include all the libraries that we will need for to run C++. So bit/stdc plus.h. So this will be our first line of code where we will include the libraries that we will need for today's workshop. Then the second line, using namespace std semicolon. So this is using the C++ standard library, some of the most basic functions. And what I like to do is to leave an empty line so that I can separate this portion with my main code to make the code look more organized. Actually, you don't have to do that. You can start writing your code on the third line. You can leave 2 or multiple lines if you want to. The compiler will essentially ignore the empty lines. So let's start writing our main block of code. And that will be int main bracket and curly bracket. So this main here, will be especially useful in the later topic of functions, where you may have additional blocks of code in your whole main code area. But this is called main because, well, this is the first block of code that your compiler will look at, and you will end off in this block of code as well. So what I mean is that when your compiler starts reading code, right, it will essentially start reading at this curly bracket. And you read through all the lines of code within the curly bracket and end off at this curly bracket. So what this means is that, well, any lines of code should be within this curly bracket. Right? If you have any lines of code outside this curly bracket, for example, if I write a line of code outside here, this will essentially it will cause an error because it's not within this block of code that your compiler look at. So note that all your lines of code will be written inside these curly brackets. You also notice that I have put semicolons, and that's because in C++, semicolons denote the end of a statement or an argument. So basically, you will tell the compiler that, well, this line of code has finished running, so I should look at the next line of code and the next line of code. If you don't have it, let's say second line of code didn't have it, right? Then the compiler will think that, well, I've already finished this, I'll run this, and where do I stop? Do I stop now, or do I continue running even though there's nothing here? So that's why we put a semicolon, just to help to denote that this is the end. You also notice that the compiler itself have given us indentations. So to create indentation, right, you can press tab. So the tab would, well, create more, you'll create a spacing, and this will help you organize our code in the later on in conditionals. And you'll see how it's helpful later on. So you can just keep this in mind. Right. So before we really start off with the actual code, I can give you a quick tip on how to take note of the codes that we are doing so far, of all the syntaxes that we'll be writing. And that is to create a new file, a text file. So in your file explorer here, what I can do is to click this button. Right. Let's create a notes file.txt, which stands for a text file. Right. And we wait for it to load. There you go. So in this text file, you can type in all the codes that we will be showing today, such as imagine if you forget how to start off, you can type it in like that, so that you can refer to this later on as you go through any practices. And unlike the main where it's all highlighted, this is all in white, and that's because, well, this is a text file, so the compiler will not execute any code in here. So you can type in anything you want, even if it's outside the bracket, it doesn't matter because it's just a text file. So this is a quick way for you to take notes as we go along through this workshop. Right. So yeah. So inside our curly bracket will be the main area where your code will go. So here. So for today, I will be going through 4 things: the data types, the variable, how to input and output, and finally operators. So let's get started on data types. So data types are essentially what kind of data should C++ look through and should understand. So I'll be explaining more details how this is useful just slightly later on. But for now, we're going through 6 of some of the more basic data types. There are definitely more data types available, but since this is a beginner session, we will just stick to 6. So the first one we have is int. So this will be how you write in your code. All the ones in the data type column, this will be how you will write it in your code itself. Okay, so an int, int, is a 32-bit signed integer, which the 32-bit means that the maximum value that this data type can hold is around 2 billion, which is this exact number here. Signed just means that it can hold both positive and negative values, and integer means, well, it's a whole number. So as some examples here, you can have 23, -4, which is a negative number, or this like 5 million. Next, we have a float, which is essentially just a decimals. So typically it has 7 dp, and just like an int, it can also hold negative values. And you'll notice that this one here, 2 by itself is an integer, but to make it a float, you can just put a decimal place 0.0, because now it has 1 decimal place. So 2.0 is a float. Lastly, we have double, which is just a more precise decimal, which is typically 16 dp. So for example, you have this like very long decimal here. Right. For the next 3, we'll have a string, which are combinations of characters, and is typically enclosed by double quotes here. So a string can be just a single word, can have 2 words, or like a random keyboard smash of multiple characters and numbers as well. So that is what a string is, just words, or in a way, multiple characters. A char stands for a single character, and it is enclosed by single quotes. So for example, a char can be an alphabet, it can be a symbol, or even a space. So in C++, a space, like a space bar, space, is considered a single character. And this will be useful later on because, well, space, we need to keep like referring to this. Then lastly, we have Boolean, which is it can only hold 2 values, true or false. So a Boolean data type can only either be true or false. If you have any questions as we go along, right, you can feel free to just type it into the chat, and me and my team will answer your questions. So that's all for the data types, and we'll be looking at variables, which will be using what we have learned about data types. Right. So like in math, where variables can hold like numbers, like different numbers. In C++, variables can hold different data. It can hold data like numbers, can hold data like words, which is why we need to be able to use the data types to help define what a variable is. So defining a variable. This is a standard practice of defining a variable. You will first write the data type, which is one of the 6 that we have gone through earlier. So the data type can be a string, integer, or int, can be a char. And next, we'll have a variable name. So a variable name must be unique. And what this means is just that if you have already declared, for example, an integer x, right? You cannot declare again a string x because, well, it conflicts with each other. And if you want to refer to a variable, then your compiler will be like, which one do I refer to? Do I refer to the string or the integer one? So that's why we must be unique. A variable name can also be a single letter, a word, or words. So it can be like, I can name my variable letter like X or Y or Z, a word like maybe the name of a person. So my variable name is just name, right? Or it can be words, like in this case, variable name. It is like 2 words. But take note that if you want to use multiple words, right, the words must be, the space must be replaced with a underscore instead. So in a way, when you, because spaces help to like separate different portions of the code. And if you use a space here, it's like you're making a new part of the code, even though it essentially should just be the variable name. So the underscore helps to like combine it into one object, if that makes sense, right? So, and lastly, the initial value. So this initial value is actually optional. It is not necessary. And I'll show some examples of how like different ways of defining can look like. So don't worry if you can't really visualize it right now. This initial value is optional. Okay, so here are some examples that we have. So remember how we define a variable, data type, variable name, and an optional initial value. So in this first example here, I have a data type of an integer and a variable name of X, but I did not give it any initial value. So in this case, X will have like a null value, which some compilers might equate it to 0, but not all. So if you want to have a variable of with a value of 0, right, it's best to just put equals to 0. So like what I have here, data type, variable name, and initial value. We have something like this: an integer, variable name, and an initial value of 8. So Y has a value of 8. You can also do it with float. And you see here, I now have 2 words to be my variable name. And our class, the space, right, is actually replaced with an underscore, so that this is like one object, you know. And yeah, here we go. Here is a float. You have a Boolean, which is a true, a char. And for char and for strings, when you want to give them an initial value, right, you have to put them in single quotes and double quotes. And the reason for this is quite simple. It's because if you have just X itself without a quote, right, it could be confused to be a variable name. So I'll give you an example of this later on. But for now, you just take note that if you want to give an initial value that is a character or a string, you have to put a single and double quotes respectively. Also, you'll see my last line here, int y equals hello world, and they'll give you an error. And that's because, well, y is an integer, so it should only hold numbers. But hello world is a string, so there's a conflict between the data type and the initial value, which is why there'll be an error. So let's say I want to declare multiple variables. They are all integers without any initial value. I could do it this way, where I have 4 lines: int A, semicolon, int B, semicolon, int C, semicolon, int D, semicolon. I could do that, but it takes up 4 lines, and you know, you have to keep writing the same things over and over again. So you have to write like semicolons like 4 times, and sometimes if you forget, then oh well, an error pops up. So what I can do instead is to shorten it like this. So when I shorten this like this, what I did essentially is to, well, combine the A, B, C, and D together. So I have int A, comma B, comma C, comma D. So essentially what they both do is the same. They both define 4 variables with a data type of integer and an initial value of 0. So in C++, both is acceptable, both is perfectly fine, and both will work. It's really up to your preference which one you will prefer. But I'll warn you that in the later practice and our answers, right, we might be using this. So in case you ever see this, you will know what this essentially just means, like this. Okay? So now that we know how to declare, where do we declare it? So remember what I said about all code for now should be in your main curly bracket, right? And because you have to declare a variable before you use it, it's like you have to have something before you can use it, right? So usually what we will do is to declare it at the top of the code. So before you write any other lines of code, we already declare it on top. Okay, and don't forget all your semicolons. All right. So if you have any questions, feel free to just ask in the chat. We'll reply to you, and our team will be there to help you in your actual code collab if you have any errors or anything, or if you're confused about anything. Okay. Okay. Next, to input and output. So now that we have variables, and how can we, like, as a user, how can we assign the variable value, and how can we extract the value from variables? And that's what we're going through today, which is inputs and outputs. To input a variable, we'll first be using cin double right arrow. So the syntax will be cin double right arrow, the variable name. You can think of it like as though from an external source, I input into the variable, right? So remember, the directions of the arrow is important, okay? If you put the wrong directions, the code will break. So remember, cin is double right arrow into the variable name. And of course, a semicolon. So before we can even input into a variable, we must first have the variable, which is why we must first define the variable like integer a and b. So after we define the variable, we can then input into a and b. Okay, so how for C++, right, spaces and enter will end the input. So what does this mean? Well, let me just show you. So let's follow the same example. I have two variables of integers, a and b, right? And I want to input into a, into b. So remember, it's cin double right arrow variable name, cin double right arrow variable name. Okay. So let's run this. So let's say I want a to have a value of 5 and b to have a value of 2. Right. I press 5. Let's say I don't press anything. I don't press any space. I don't press enter. I just think, oh, I press 5, so that'll be a. I press 2. Will that be into b? I can just keep pressing, right? You notice that the code, I can just keep pressing. And that's because, well, the compiler don't know if you have finished inputting or not. There's no indication to tell you that I already inputted 5 and I want to stop. So what you can do is to press enter, right? And now when I press enter, the compiler knows, okay, I've inputted into A. So now the next input shall be into B. Press enter. I press 2 and I press enter, and you can see that the code has finished running. So this is what this blue text is. This means that the code has finished running. So this tells me that when I press enter, right, the compiler knows that, well, I finished inputting into A, I finished inputting into B. So similarly, if you want to do for a space, right, you do a 5 space 2, right, and I press enter. Yeah, it has entered because now the code knows that I finished inputting into A, I finished inputting into B. So that's what I meant when I say spaces and enter will end the input. And lastly, inputs can be condensed to save space and organize. So previously I was using this as a way to input, but actually I can in fact condense it to like this. So instead of writing cin twice, I can cin double right arrow into the first variable, followed by double right arrow into the second variable. So this is a quick way to shorten your code to make it all organized. But both is perfectly fine and perfectly workable. Both will work anyways. Next, we will have the output. So now that we can input, we want to be able to extract values from it. So what we'll do is to output. So the syntax will be cout with a double left arrow this time. So you can see my cin is right arrows, my cout is left arrows. The arrows are very important. Okay, make sure you get the directions correct. And that is the cout double left arrow variable name and your semicolon. So before you can cout, right? Before you can output or extract value from a variable, well, the variable must have a value for you to extract. So in this case, my variable x already has a value of 8. So if I were to output x, I will get 8 because, well, x is equal to 8. I can also output something like a string. So this is my variable name string. I give it a value of hello world. And if I cout, I will cout hello world. Similarly to cin, cout can also be condensed. So I can put, if I want this to be my first output, I will put it here. If I want this to be my second output, I put it here. So 1 and 2. So cout, double left arrows, your first variable, double left arrow, your second variable, and followed by a semicolon. So this is very similar to cin in the way of how you can condense it. It's just that this is now cout and the arrow has flipped directions. Okay. You don't only have to output variable, you can actually just output values directly. So if I want to output 8, I don't have to make a declared integer with 8 just to output the integer, just to output the variable. Instead, what I can do is just output the number straight away. So I can just cout 8 and it'll just come out 8. I can also cout strings and characters, but as usual, you have to make sure that it has put your single and double quotes. Well, since now that we have learned a bit more about some syntaxes, let me show you why this is important. Okay, let's say I have an integer of 8. I'll give you a value of 8. And I want to output the character A. If I don't put the single quote, right, output the character A, I don't put a single quote, what do you think will show up in my console here? It will show up an 8 instead of an A. And that's because when the compiler looks at this, right, it will think that, well, we want to cout 8, and 8 is a variable, it's a name of a variable. So thus it will cout the value of the variable A. That's why if I want to have a character, I should put it in single quotes. So if I run this, well, first thing first, before I continue, you will see that this is a warning because I did not use this variable, but it doesn't mean that my code is wrong since this is an example. So you can just ignore this whole portion. But you can see that my output is an A instead of 8. So this is why quotations are important here. Right. So just to summarize, output characters, you need single quotes. Output strings, you need double quotes. And like as usual, you can also condense your outputs into one line. Okay, one thing to note, right? Let's take a look at this. I have a variable x with a value of 8, and I want to output the variable name, output the variable, and output hello world. What do you think will come out as the output? This will come out if you decide to try it. This will come out. This is right in a way, but you'll notice that they are together. So what we can do is, if we want them to be separated, we have to manually output a space, which is why the character is so important in C++, because of how you want the output to look like. You need to manually output a space. It will then lead to, well, a space. You'll notice this is a difference, it's a space. So that's one thing you need to take note of. If you notice that, oh no, all my outputs are together and I don't want them to be together. And that's because you didn't have a space. So next we'll have something, another like output formatting is to have a new line. So if you just output this, see out hello world and see out new day, you notice that they're all on one line. And if you want them to be on a second line, like a bit below, right? What I can do is to use this \n within the code, or double left arrows and NL. It stands for end line. So this is an L, okay? It's not an I, it's an L. And NL stands for end line. So what this does is you make your code look like this. So you can see the difference clear as day. There's a new line. Okay. So I hope everyone is been keeping up. I'll just leave this on for a while for you to like well, note it down, I guess. Okay. We have copied or at least taken a screenshot. So here is a quick summary. Well, this will be up for like maybe 1 minute for you to take a screenshot and to really write it down. I think it will be quite useful later on during your practices. So remember your first two lines, your main, how you declare a variable, how do you input, how do you output, and also how do you output. So I'll just give you guys about like maybe 30 seconds to just note this down. I hope everyone has taken this down, or at least taken a screenshot, taken a picture. If you haven't, do it like right now, because I'm going to exit this slide in like 5 seconds. Okay, so next. So let's start with a practice to really consolidate what we have gone by so far. Right. So I, as the user, will input two strings, a name like John and a word like hello. Your code should output this in this format. Okay, your code should output in this format. The name, said this, colon, a new line, the word. So in this example here, where my inputs are John and hello, my output should be John said this, colon, hello. Right. So I'll give you guys about 5 to 10 minutes to try this, and I'll go through the answer at that after the time is up. Okay, so I hope everyone is done with the practice, and I'll be going through the answers now. Right. So we go through. Okay, so let's start our basics. Okay, so let's start. Let's analyze the questions. So the user, I, will input two strings, name and word. So I want to input two strings. So obviously I have to use the cin function, the cin double right arrow, and I need to put it to two strings. So before I can use the cin, I must first declare the strings that I want to use, right? So let's declare it first. So string, because two strings, and well, conveniently, I already written here name and the word. So conveniently, right? Name, word. Remember, I use a comma to, well, separate, to condense it. But if you want, you can also write it like this, and your semicolon. Okay. You can also write it like this. Both is fine. So I have my two variables. Time for me to input into them. So input cin, double right arrows, name. And I want to, okay, for me, I want to combine them together because I don't write cin again. So what I do right now is do another double right arrow, word. So now I will input into name and input into word. So now we have already settled the first line, input two strings. Now I want it to be this format. So output name said this word. So well, output is the out. left arrow this time, my name. Another 2 more left arrows because I want to combine them together. Say this. But do you think this is correct? No, because this is not in quotations. So I had to put it in quotations. And this is still not correct because I have a space here, between the variable name and the state this. I have a space here, but I didn't put any spacing here. So the name and the word state will just like be connected. So I put a space. And my next line should be on a new line. So I'll end this off with an end line. End line. Let me just like hide this so that there you go. End line. And I'll put a semicolon to end the statement. So semicolons, don't forget. That is just the first half of my output. So now I want to output the word. So I just need to output the word. So it's simple as that. Let's give this a run. It's loading my file. So give me a second. Oh. So, John. Hello. See, John said this. Hello. John said this. Hello. And the thing about this is that this John and hello is, well, determined by the user. So I don't have to be John and hello. It can be like Tim. And like you said bye. So Tim said this. Bye. So yeah. So this is the answer for the practice. Okay. I hope anyone got any questions, you can just ask in the chat. So the last thing I'll be going through today is the operators. So now you got variables. You want to, well, use them with each other. You don't want to just input and output it, right? So variables are used to manipulate, operators are used to manipulate variables. And usually, I'll highlight the word usually, it's only between two variables of the same type. So what this means is that I can use variables like int and int together. I can manipulate between a string and a string together. But the word usually is because actually you can manipulate an int and a float and a double together. And that's because, well, int, float, and double are essentially all just numbers. So I guess C++ doesn't find it too confused. You can also manipulate between a string and a char, a string and a character, because if you think about it, a string is just a combination of characters. And well, there is instance where you cannot manipulate, and that's you cannot manipulate an integer and a string together because they are totally different. Like this is a number and these are characters. So this is something you take note of. C++ kind of weird in that aspect, but oh well, we'll do with what we have. So here are some operators that we will have, some basic ones. We have plus, minus, times, divide, and remainder, or modulo. So this will be your plus symbol, minus symbol, your asterisk, your dash, and your percent symbol. Some examples here. 5 plus 2 becomes 7. 5 minus 2 becomes 3. 5 times 2 becomes 10. 5 divided by 2 becomes 2. Well, you will notice, oh no, you think that, oh, did I make a mistake here? Isn't 5 divided by 2 2.5? Well, no, I don't make mistakes here. You will realize why this is so in the later part. So just keep this in mind, why 5 divided by 2 is actually just 2 and not 2.5. And finally, your remainder, 5% 2 becomes 1. Okay, I hope I don't have to explain why this is so. There's some special operators that you don't see in math, you see in C++. Is something like plus, plus, and minus, minus. Okay, so what this does is it adds or subtracts 1 to the variable. So let me just give you an example. Integer x, let me give it a value of 5. Right. And let me just quickly just write C out X. Let me give this a run. I expect a value of 5. There you go. Let's say I want to add 1 to this like in my code. Right. I can use this X plus plus. And what this does is that this line adds 1 to my value of X. So that is a 6. If I add another line of this, run, it will give me a 7. If you load, there you go, a 7. So similarly for minus minus, right? You minus 1, and you become a 3. There you go. So this is the short form, in a way, the short form way of writing this. What this like X plus plus is, right? Is actually X equals to X plus 1. So like you can think of it like your new value of X is your old value of X, which is, well, let me just remove this. Your new value of X is your old value of X, which is 5 plus 1. So 5 plus 1 is 6. So X is equals to 6. There you go. X equals to 6. So that's what this row means. The next one will be plus equals, minus equals, times equals, and divide equals. And that is because that is like another subset of this, right? Is that you see for plus plus you can only add and subtract 1. But for this, you can actually decide the value you want to add and subtract. So how I write is, so basically how you write this will be X plus equals to a value. So this will be how you write it. X plus equals a value. So you say X plus equals to 7. And you run it. You add 7 to X, which will give you 12. So that's the same. It is basically not 1. Like you can put in this is when this is just 1, right? This can be any number that you decide. So that is your plus equals, and the rest of this. Lastly, we'll have comment, which is just two slashes. So a comment is basically it hides the code from the compiler. So you can notice that when I type the 2 slashes, right, this line turns green. And if I were to run this, it will come out 5. And that's because this line of code is hidden. It is as though there's nothing there. So the code only sees like this, even though we see it like this. So that's what comment is. Okay, so back to previously where 5 divided by 2 is apparently 2. Let me just show you it. Yeah, let me just tell you that I'm not actually lying. Okay. If I int x equals to 5, okay, I have int y equals to 2, and I want to see out x divided by y. Okay, I am not lying about this. I can show you. So for it to appear 2. See, I did not lie. 5 divided by 2 is 2. And that's because, well, this itself is an integer. And that's because both its parent variable, x and y, are integers. So this x divided by y, this like whole term, is an integer. And what an integer does is that the actual answer is 2.5, right? What the actual integer does is that it just deletes anything after the decimal place. It doesn't round up, it doesn't round down, it just deletes it, which is why the output is 2. So to, well, not have this happen, right, what I can do is to make one of the variables a float. Okay. And essentially, let's take a look at what happened. Now it's 2.5. So now let's take a look at what x divided by y is now. It can, both its parents are different. X is an integer, y is a float. So which one does it choose? Well, C++ will decide to take the one with decimal places because it can hold like more data. So that is why x divided by y is now a float. We can now hold a decimal place. Yeah. So I hope everyone can understand this part of the portion. So that's a quick summary of what it looks like. If you just change one of them to a float, your output will change also. So just beware when you declare certain variables. So far I've been giving you all just numbers. You can also perform operations like summing with strings as well. So let's say I have 3 strings, okay, S1, S2, S3. S1 is hello, S2 is whoa. I can actually add up a string, another string, and like a space. Remember, spaces are important, a space. So I can add up S1 plus a space plus S2, then S3 will just be hello world. So you can also add that in. So strings can also perform summations. All right, so I hope everyone's keeping up because we'll be going on to the next practice. So the next practice is I'll input 2 numbers. So for example, 5 and 3. You would have to perform a division operation. So divide 5 divided by 3, followed by squaring the answer. So you take 5 divided by 3 times 5 divided by 5 divided by 3 times 5 divided by 3. And they'll give you this. My bad. They'll give you this. Right? So I'll give everyone about 5 to 10 minutes again to try this. Hope everyone is done. And I will begin the answers. Okay. Okay, let's have a brand new page. Brand new start. All right. So what I need to input 2 numbers. So to input a number, I need to first declare the variable. I'll declare it. I'll explain why I declare it like this. Okay. But first, I'll declare the 2 variables. So why did I choose to declare as a float and not an integer? And that's because, like what I said earlier, if you divide integer with an integer, you get an integer. And that's not what I want. As you can see from my results, I have decimal places. So no integers. What I have is now a float. And you notice that even though I input as like an integer, I input without a 0.0, right? The compiler is in a way smart enough to know that I can put a point. The compiler knows that it's smart enough to know that there's a 0.0. So it still works out. Right? And let's say I just want an answer. I want an answer variable so that I can, like, I don't know, just look nice. Okay, so now that I've already declared the 2 numbers that I want to use, I have to input it. So input is your cin, double right arrow, your first variable, double right arrow, your second variable. So that will be how you input. So now let's make the answer. Answer. First things first, division operation. So I have to first divide. So let me just divide x divided by y. But now I have to square the answer. So what is squaring? A squaring is multiplying a number by itself. So what I can actually do is to take this bracket, right? It's like similar in math with your board math. It's a similar system. So you'll go bracket first, then your operators. So now I have x divided by y times x divided by y. So that is squaring. So I divided and then I have squared it. So now I can just output my answer. So let's just give this a try. Let's see. Is the number of it's 5 and 3. get an answer. I did get an answer. 2.7778. So there you go. So this is the answer for practice number 2. Right. So I'm done with my part. So the next person taking over me is Iker.
Okay, hi guys. So now it's 2:20. So let's begin. So I'm going to bring you through conditionals. Okay. So first, what we need to understand is what is conditionals. So conditionals comes from the root word condition, right? So condition is things we use in everyday life. For example, I will go out if it's not raining. I will bring my umbrella if it's raining, right? So these are called conditions. So we can also use these conditions in C++. So before I go through view conditions, we need to know some operators first, okay? So first we have these four, the very basic ones. We have equals, equals. And like Ling Song mentioned, the things on the left-hand side is exactly how you would write them in C++. Okay, so first we have equals, equals. This means is equivalent to, okay? So as you see the example on the right side, you can see 5 plus 3 equals to 10 minus 2. What does this mean? This basically means is 5 plus 3 equivalent to 10 minus 2. So since 8 is equivalent to 8, thus this will produce true as an output, okay? Similarly, the next one, we have exclamation mark equals. Okay, this means not equivalent to, which is the opposite, right? So as we can see here, is 2 times 5 not equivalent to 10? This will give false, right? Because 10 is equivalent to 10, right? So the next two, we have more than equals to, less than equals to, which is quite self-explanatory. So similarly, the example is 10 times 2 more than equals to 3. Is 20 more than 3? Yes, right? So this will give true. Next, we see is 20 less than 7? That's not true, right? So we have a false because 20 is more than 7. Okay, so these are the 4 basic operators for conditions that we have to understand, okay? And we also have to understand that conditions all have to return a Boolean value. Like Ling Song mentioned, Boolean values are true or false, 1 or 0 values, okay? So next, we're moving on to the AND and the OR operators, all right? So the AND operator gives true if both events are true, right? But before, it's just true or false, right? It's just simple as that. But now, it will give true only if both events are true. So what does this mean? Let's take a look at the examples on the right. As you can see, we have 2 of something that we learned before, right? The equivalent and the not equals to. Okay, so similar to maths, we want to do what's in the brackets first. Okay, so we take a look at the first bracket. Is 1 plus 1 equivalent to 2? It is, right? So the first part is correct. That's true. Second one, second bracket, is 2 plus 3 not equals to 4? That's also true, right? Because 5 is not equals to 4. So since both events are true, the whole thing is true, right? Like the definition says, right? So next we have, is 2 plus 3 equivalent to 5? Is 5 equivalent to 5? Yes, right? So this is correct. Next we have, is 5 minus 2 more than 5? So is 3 more than 5? No, right? So by definition, this is false because only one is correct. However, let's move on to the next one. The OR operator gives true if at least one of the events is true. So only one needs to be true for the whole thing to be true. Okay. So now you can see here, as before, we do the ones in the brackets first. Okay. So is 5 times 2 more than 4? Is 10 more than 4? Yes, right? So this is correct. Is 2 plus 1 equivalent to 3? Is 3 equivalent to 3? Yes, right? So since both are correct, and since both are correct, this will give true. Okay. So now the next one, let's take a look at this. Is 5 times 2 equivalent to 4? Is 10 equivalent to 4? No, right? So this is wrong. However, the next one is 5 plus 5 equivalent to 10, right? Is 10 equivalent to 10? Yes, right? So by definition, since at least one of it is true, this will give true, right? So this is the difference between the AND and the OR operator. All right, so now we learned the basic operators of C++. Let's move on to how we use them. Okay, so now we use this thing called, all right, okay, they're both Boolean values, and we use this thing called if statements. Okay, if statements. This is something I mentioned before, like if it's raining, we don't go out, right? So this is the basic syntax of how you write the if statement. If, open bracket, the condition, close bracket, or curly brackets, and you do whatever you want within the curly brackets. Like Ling Song mentioned, you have to do the processes within the curly brackets, okay? And this condition has to be a Boolean value, as in return yes or no, true or false, right? So this is an example. If it's raining, if it's true, we don't cycle to school, right? So this is just an example of how to use the condition, right? And this equivalent sign is what we learned earlier, right? Is raining equivalent to true? So if it is raining, we don't cycle to school. Okay, so this is just a hypothetical variable and just a scenario. So it's not really practical as of now. So it's just helping us visualize how to use the if statements correctly, okay? So now we've talked about one side, right? We've discussed if it's raining, but we haven't talked about what if it's not raining. Okay, so now let's discuss the other side, right? We discussed this side. What about this side, right? So now let's bring in something called if else statements, right? This else is new. So how do we write this? So again, we write the if statements as normal. However, we add an extra else at the end of it. Else, open curly bracket, whatever you want to do, and close curly bracket. All right, so this else is basically ran only if everything on top is not met. For example, if this condition, which is a Boolean value, if this condition is true, and then this condition will be false. If this is false, this will be true. All right, let me explain. So if it is raining, cycle to school. If it's not raining, if it is raining, you don't cycle to school. However, if it is raining, you cycle to school, right? So this else is like the last resort, okay? If everything on top fails, we go to the else, right? If is raining is true, we don't cycle. However, if it's not true, we cycle to school, okay? So yeah, so this is the basic syntax for the if else statements. And yeah, so let's have a short practice now since we've gone through. I want you to take in an integer x. We check if the integer is even, and then we want to output the string true. If x is odd, we want to output the string false. Okay, so how do we do this? Right, so some hints. We use cin to get the input, which is a recap from what Ling Song had mentioned earlier. We're going to use cin and cout a lot for C++. So be sure to get that into habit. All right, so now we've gone through taking an integer x. How do we check whether it's even or odd? So I want you guys to think about this. Use x%2 equivalent to 0 to check if it's even. But why? I want you guys to try to remember what does the percentage sign mean. Okay, so I've sent the slides have been sent in the chat, so you guys can scroll up to review what does percent mean. So I want you guys to think, why does this help to check if it's even? Okay, so we'll give you guys about 5 minutes to try this out, and I'll go through with you guys afterwards. All right. So yeah, so please try it, and so to get a understanding of how this works. Okay. Yeah, I'll get back to you in 5 minutes. Okay, hi guys. So now we're done. So let's go through this. Yeah. Okay. So first we want to declare a number, right? Okay, let's say x. Declare a number, and then we want to input the number. As Ling Song mentioned, we use the outward, the right bracket to put into x, and then we're going to use this, right? So as mentioned, this is the apologies, some lag. All right. Yeah, all right. So as mentioned, this was the basic syntax, right? Oh, oh my god, condition. Yeah, there you go. All right, so this is the basic syntax for the if statements, right? Maybe one add else here. Yeah. So what should be here, right? As I mentioned, if x %2 equals to 0. So why does this work? Okay, so I need to understand that %2 means the remainder, right? So if I divide something by 2 and the remainder is equals to 0, that means it's divisible by 2, right? And all even numbers are divisible by 2. So this is a very smart way, effective way to check if a number is divisible by something, by checking if the remainder is 0. Okay, so now once that's done, we want to see out true, right? True. And then don't forget your semicolon. True, false, right? And yeah, output true if it is, else, otherwise if it's not, output false. Okay, so let's run this and let's show you how it works. Okay, so now we put 2. That's true, right? Because 2 divided by 2, the remainder is 0, which shows that it is even. Let's try another number, right? Let's try 10. Yep, 10 is true because 10 is divisible by 2 and the remainder is 0, right? So now let's try an odd number. Let's try 11, okay? And it'll give false, right? Because when 11 divided by 2, the remainder is not 0, hence it goes else, output false. Okay, hope that's clear. If it's not clear, please ask any questions in the chat. My team and I will gladly answer you guys. Okay. So yeah, so this is the flowchart of the practice. So what if now we have multiple continuous conditions, right? It's not only one true or false, one yes or no, there are more, right? So what I mean by this, so just now we looked at this, right? If it's not raining, we cycle to school. If it is raining, we cycle to school. But what if we want to ask ourselves more questions? Like, do I have enough money? And if you do have enough money, you take public transport. But if you do, take taxi to school, right? So this is the continuous condition I was talking about, okay? So like in methods like this, we can't just simply use if else anymore, right? Now we have to use something called else if statements. So this is a basic syntax. Similarly, there is still the if at the start and else at the end. Just that we add this new else if in between, right? With these two conditions being Boolean, right? So what this means is if the first condition is not met, it'll jump to the second condition. If the second condition is not met, it'll jump to the else. And you can add as many of these else ifs as you want in between. As long as they're not met, it'll just keep going below and below and below until it reaches else. Okay? So, for example, if it's not raining, we cycle to school. Else if we have money, take taxi to school. And else we take a bus to school. Okay? So if this is not true, if this is not met, it'll go down. If this is not met, it'll go down. So it just keeps going down, yeah, until it reaches the else. Because as I said, else is the last resort. So else is if everything else above it doesn't meet, it'll jump to else. Okay? So yeah, if it's not raining, we cycle to school. Else, if we have enough money, we take taxi to school. Else, we take the bus to school. Okay, I hope this is clear for everyone. Yeah, if you have any questions, please ask, and we'll be more than happy to answer you. Okay. Yeah. So what if we want to extend it even further? All right. What if we want to know more stuff, ask ourselves more questions, like this flowchart over here, right? We need to ask ourselves, we have enough money, are we late for school, our parents busy, and we need to do all these processes, right? What if all these are continuous conditions, right? We sometimes else if may not be enough. Okay, we need something called a nested if statement. So what does this mean? Right, we'll go through this with this example over here. Okay, and you can see I'll put the flowchart on the right side so it's easier to visualize as we go along. So first we start at the top. Is it raining? You ask yourself, if it's raining, is false. We cycle to school, right? So now we're done with this top left section over here. So let's move on to this bigger area over here, right? So now, if it's raining is false, we cycle to school. Else if, like what we've done before, else if we're late for school, which is yes, we want to ask ourselves now, do we have enough money? So now, if we're late for school, we want to ask ourselves if we have enough money, right? So we can also add in another smaller if statement within this larger if statement. As you can see by this blue and red bracket, this blue bracket is just a smaller if statement within a larger if statement. This is what nested if statements mean. The smaller if statement is nested within the larger if statement, all right? So now we've settled this part over here on the flowchart. You can see we ask ourselves if we have enough money. And yes, we take a taxi to school. So now we need to branch out to this area. We need to ask ourselves, are our parents busy? So thus we use the else if, right? Like before, if we don't have enough money, then we ask ourselves if our parents are busy. So if our parents are busy, it's true. So they are busy. We cry and take public transport, right? Because we'll be late for school. So if they're not busy and we don't have enough money, then we can ask them to send us to school, right? Since they're not busy, they'll be more than happy to send you to school, right? So now we're done with this smaller if statement, but don't forget to go back to your larger if statement, right? As you can see in the flowchart, we have still one area that's not highlighted. And now we need to access this, right? We need to address it. So if it's not raining, if it is raining and we are not late for school, right? If it's raining is true and late for school is false, as I said, else is the last resort, right? Else if everything on top fails, we jump here. So if everything on top fails in the if statement, we jump here. If everything on top fails in the small if statement, we jump to the smaller else. All right. So hope that's clear. Please clarify if you have any doubts. All right. So yeah, so now let's move on to a practice. Okay, so here we have a grading board, all right, just a standard grading system. So I want you to take in an integer, similar like what we've done before, take in an integer and output the corresponding grade with the score, right? For example, if our score was 95, we output A star. If our score is 60, we output B. If our score was 49, we output F, right? So how do we do this? So this may seem a bit daunting at first, like how do we address all of these numbers, right? So of course, let's break it down, right? Let's make it simpler. So this is how humans understand, it's easy for humans to understand, right? How do we express it mathematically? So we want to use something called inequalities, right? So let's say S is our score, right? So in maths terms, in order for an A star, the range of values for S have to be in between 90 to 100, right? So S has to be within 90 to 100 for an A star. Similarly, for A, it's in between 70 to 90, right? And then for B, just so on and so forth, right? So yeah, so this is how we mathematically express our scores to represent the grade, right? So now we have that. Now we have the mathematical conditions, right? So these are the conditions for the score for the respective grade, okay? However, C++ doesn't really understand this, right? It's a bit lazy. It has to understand in its own language. So how do we translate this to C++? So we can do this by using the AND operator as we've done before. So as you can see, these are technically the same, right? Because if S is in between 90 and 100, it's also technically more than 90 and less than 100. Right? So this is how C++ understands inequalities like this, right? We have to use the AND symbol, right? The AND operator. Similarly for the others, yep, it's just the same, so on and so forth. Okay, so these are the conditions required for C++ to understand, and then you can output the corresponding grade using these conditions. Okay, I hope that's clear. So yeah, so this is the flowchart of how this program works. So we have the condition for A star, and then we output A. If it's not A star, we check again. We else if the condition for A, output A, else if condition for B, output B, else if condition for C, output C, and then last resort F, right? So yeah, this can be a bit long to do, so I'll give you guys about 10 minutes for this, okay? All right, why not I'll just start you guys off with the basic structure. So this is just the basics. You guys already know this by now. So if if s blah blah blah, if condition, then we do something, and then else if blah blah blah, we do something, and else if else if blah blah blah, we do something, and then so on and so forth until you reach else. All right, so this is just the sort of skeleton or the framework of how you want to write your code. So yeah, you can use this if you want, and yeah, I'll give us about 10 minutes from now. We'll come back at 2:54 p.m. to discuss the answers. All right, thank you. Okay, guys, so according to my group mates, a lot of you guys have done it, which is very good. I'm glad you guys are keeping up. So yeah, so let's go through it now. So let's for A star, right? Oops, A star, right? So when check, as you mentioned earlier in the previous slide, we can use these conditions, right? We can put, all we need to do is put these conditions into their respective if statements, right? So if our score is more than equal to 90, and our score, hold up one sec. Oops. Hope you guys can see if it's smaller. Okay. This equals to 100. And then yeah. Then we see out A star. All right. And then just just see everything. Then A. Now we have the second condition, which is oops. Okay. This is for A. Okay. So this is the first condition, and for A we have s more than equals to 70 and s less than 90, right? So yeah, I want you guys to try this out and type along with me if you guys haven't, so you guys can have a better understanding of how to do this and how to implement if statements. Because for programming, if statements is basically a necessity. In everywhere you go, you always are going to use if statements, right? So yeah, so I guess we can just keep copying this and then just changing the numbers, right? There we go. And then 50. And yeah. Oops. Ooh, okay. All right. So change the grade, B, C, and then finally F. Right. As you can see, we use the else for F here because this is the last result, right? If it doesn't meet any of these conditions, we'll jump to F. Okay. So yeah, so let's run this and let's see how it works, right? We got 50, right? So since 50 fails this condition, it jumps to here. If fails this condition, it jumps to here. If fails this condition, it jumps to here. And this is true. So thus, it'll end here, right? It'll stop here. Since this is already true. It jumped from here, jump down, it jumped down, and then jump here, and this is true. So thus, it'll output C. Okay, let's try again. Let's run. Let's go 90. All right. So we're gonna A star, right? Because immediately at the start, it passes. So it already goes here and it ignores everything else below it. All right. It ignores everything else below and ends here. Okay. So now let's try. Let's try 30. All right. You didn't study a lot. And now we got F. Okay. So why you got F is because we failed this. We jumped below. failed this, we jump below, we failed this, we jump below, failed this, and then finally the last result, we get the bottom one, okay, which is F. Right, I hope that's clear. This is a lot of many lines, so you guys can like take a screenshot if you need the answers. If you don't, good for you. Okay, so this is how to utilize else if, and there is another method. Is we can start from the bottom up. Okay, so we check if our score is less than 50, right? So in this case, if our score is less than 50, so in this method, we don't need to use the AND operator, right? Okay, so immediately if it's less than 50, you already know it's F, right? So else if we use S less than 60, right? And then see out. See, so this is more of a bottom-up approach as compared to just now where we use the top-down approach. So yeah, so else if else S less than 70, then see out B, then else if S less than 90, we see out A, and then else we see out A star. All right, so this is another way of doing it. As you can see, is the conditions are a little bit shorter as compared to the previous one, because in this one we don't use an else. So why does this work? Okay, so this works because we accounted for all the numbers. All right, so first we accounted for all the numbers which are less than 50, right? So we already accounted for all the numbers that are less than 50. So this will result in F. So why does the second one work, right? Why does the previous method we need an AND, but this we don't need an AND? Because for this case, we already accounted for everything below 50. So technically here, what's happening here? We're checking if S is 50 to 60. Right, I hope that's clear. Since we already accounted for everything below 50, the next line of the if statement is referring to everything from 50 to less than 60. Okay, similarly, for 60, we already accounted everything below 60. So for this third if statement is technically from 60 all the way to 70. Okay, and then so now we accounted everything below 70. So now for the third if statement or the third else if statement is the 70 to 90, right? So on and so forth until we reach the end where it's only 90 and all the way to 100. Okay, so yeah, so this is another method. So yes, you can take a screenshot of this as well if you guys want to. Just a shorter method, but a more abstract way of looking at it. Okay, so 5, 4, 3, 2, 1. Moving on. So now we're done with conditions. Okay, so now we're going to talk about something a little bit more complicated, but we'll still use conditions. Okay, so it's called loops, right? So first, what are loops? So loops allow us to repeatedly execute a block of code until a given condition is met. For example, I want to keep doing this. I want to keep studying until I get an A star, right? I want to study every day until I get A star. So that's the loop, technically. You want to keep doing something again and again until a condition is met. Okay, so why do we need loops, right? So for example, I want you to output all the numbers from 1 to 10, right? Like print 1, 2, 3, 4, 5, 6, all the way to 10, right? You can simply just do this, right? Just write all the numbers manually from 1 to 10. But what if I ask you like 100? Are you going to write 100 numbers? If I ask you 1,000, are you going to write 1,000 numbers? If I say 10,000, are you going to write 10,000 numbers? Obviously not, right? This is not efficient at all. So yeah, so this is why we use loops because computers, they love repetitive stuff. So we use them, right? So before we begin, I want to go through the basic sections of a loop, right? Different parts of a loop. So for the very fundamental loop, we have a counter, we have a terminating condition. As you can see, condition is used again as we have done before. Conditionals, condition, terminating condition. I'll explain what terminating condition means, but just understand that this is just a condition that we have gone through before, right? Using the ifs or the the conditions that we've done. So next we have an incrementation, like you want to increment the counter. Okay, I explain in much detail later on. So regarding the example I gave, for example, I want you to count from 1 to 10, output all the numbers from 1 to 10. This is a flowchart of how we do that, but instead we're counting up to 5 only, right? So I'll explain how this works later on. So this is just an idea of how a loop works. So as you can see, we have the counter. We have, like Ling Song said, you initiate. This is just a flow chart, so this is not C++. So we don't have to declare integer at the start. Just for your information, it's just a flow chart to help you visualize what's going on, right? So next we have the condition, and then we have the incrementation, right? We increment the counter, okay? So let's go through step by step how this flow chart works. So first, we start, as you can see, the right-hand side. Yeah, counter is 1. Now we check, as you can see, I'm highlighting in green. We check. We use a condition to check if the counter is less than or equals to 5, and if it is, we output the counter. As you can see, we output 1. Okay, and then we increment. And we go back. We go back to the condition. So we check again. Is the counter less than or equals to 5? If it is, we output, right? And then we increment again, right? And we check again, and we output, we increment, we check again, we output, we increment. As you can see, this process goes on in a circle, right? Like a loop, right? Circle. That's why it's called a loop. Again and again and again until this a condition is met. Okay, so now we output 5, and then now you see counter is 6, right? And see on the right side, counter is 6. So now that we ask ourselves, is the counter less than or equals to 5? Right? Is it still less than or equals to 5? No, right? So therefore, we end the loop, right? So we end the loop. So this is why it's called a terminating condition, right? Because this condition has to terminate and it will end the loop, right? Because you don't really want your loop to go again and again and again and again and again for this case, because it's not really practical, right? Because you only want to count from 1 to 5. You don't want to count infinitely, right? So yeah, so that's why it's called a terminating condition. And also, as you can see, we have successfully outputted all the numbers from 1 to 5, right? And we can do 10. You just change this value to 10. We can do 1,000, 1,000,000. Just change one value, right? Just simple as that. We don't need to manually type all the numbers. We can use a loop to help us. Okay, so that's basically the idea of how a loop works. So for programming, there are 2 basic types of loops we need to know, and they're similar, but they're kind of different. Okay, so we'll go through them in today, right? So first we have the while loop, and then we have the for loop. Okay, I'll go through what a while loop is first, since it's a bit easier to understand. So this is the syntax for while loop. As I mentioned, it's simple to understand, as you can just, is something we've done before. It's like if statements, but just change the if to a while, right? So this means while this condition, which is a Boolean value, which is true or false, if it's met, I want to do something. Okay, so while this condition is being met, I do something. Okay, so let's scratch this. Okay, so now let's write it down. Okay, so as I mentioned, we must have a counter. Let's start a counter, a condition, and then we increment it. All right, so a counter while, so we have condition, for example, counter less than or equal to 5, like what we did before. Then our output counter, and then yeah, as Ling Song mentioned, and L, and then I'll increment the counter, yeah, by 1, right? This is just +1 to the counter. Okay, so now you see we have the basic function, basic sections of the loop, right? We have the counter, we have the counter, we have the condition, and then we have the increments. We are incrementing the counter, all right? Let's run this and we'll see. Yeah, as you can see, we output all the numbers from 0 to 5, right? I mean, change this to 1 if you want. Okay, so let's change this number as I mentioned earlier. All you have to do to count is you just change one number, right? Simple as that. Let's say 100. Okay, let's see if you can see. Yeah, we print all the numbers from 0 all the way to 100 just by changing one number, right? As you can see how efficient loops are, right? We don't have to type 1, 2, 3, 4 all the way to 100, right? So this is a very interesting thing about loops, right? It's a very efficient thing about loops. The computer does it for you, okay? So you guys please type along what I'm doing so you guys can have a better understanding of how things work and see where you are missing and clarify with us your doubts, okay? See, I'm just gonna leave this on for a few more seconds if you guys want to copy it. Okay, yes, and yeah, all you need to do is just change this number. It can be 1 million or like 10,000, up to you, right? The only thing that's gonna change is how the time, right? How long the program is gonna take to run it. Okay, but other than that, it's pretty straightforward, and it's just counter, condition, increment, right? While this condition is being met, I will keep doing this over and over again until this is false, right? And then I'll exit the loop, right? Like you saw in the flowchart, right? I'll go again and again and again until I end it, okay? Right, so now moving on. Now down while loops, let's talk about for loops. So for loops are a bit, okay, the function is the same, but how I write it is different, all right? So this is the basic syntax of a for loop. Okay, so at first glance, you can see it's broken up into 3 portions, right? So first, of course, we have the counter, followed by a semicolon. You have a condition, semicolon, and then we have the incrementing, and then a close bracket. And then like all the other things that we learned, everything has to be within a pair of curly brackets, okay? I'm gonna do something here, all right? Let's write it down. I won't get rid of this. I'll just comment it. Oh, by the way, you can comment large chunks of stuff just by pressing control slash, yeah, like that, to like comment large chunks of stuff. Okay. Yeah. Okay. So now let's talk about for loops. So as you can see, for loops we also have a counter. Which is this different than while loops, because while loops you define the counter outside the loop, right? You can reuse this counter elsewhere. But for loops, right, we define the counter within the loop itself, not outside, not outside here. Oops, not outside here, right? But we define it within the loop itself. Okay, so now we have the counter, and then let's do the condition, and then we have the incrementing. Okay, so yeah, then curly brackets, and then we type whatever we want inside this curly bracket, right? Anything here. Okay, so the thing about for loops, right, is it automatically increments it here because it's part of the syntax, right? We have to write it, unlike the while loop, whereas we have to write it manually ourselves within the loop, right? It's not required to write it, but if we don't, we'll end up with an infinite loop, right? However, for loops, we have to write it in order for the code to work because it's part of the syntax, right? So yeah, so that's the main difference between the while and for loop. The while loop, you have to write it manually, not really both manually, but it's not required in the while loop. But for the for loop, it is required. Okay, so yeah, so let's try to do the same thing by using a for loop, right? So yeah, so basically there's 3 lines, simple as that. So as you can see, this is the same output line, but we don't need to write this. We don't need to write this, right, in the for loop because we already wrote it here at the start when we wrote our for loop. So as you can see, this will give the same result. Okay, 0 to 5. Okay, Because what happens here is the same thing. At the start, you initiate this 0, and then you run the process. Sorry, you initiate 0, you check, you run the process, you increment, and then you check again, you run process, increment, check again. You know, like a loop, right? Similar to the while loop. Just that this the incrementing is on top rather than below, right? Rather than below here, right? It's at the top now. Okay. So again, I can put 100 here. It will still work the same way as the while loop. Okay. As you can see, it's 0 all the way to 100. Okay. So yeah, I'll leave this here for a few seconds so you guys can copy if you guys want. Okay. All right. Okay. Yeah. So now we're done. So now let's see, as I mentioned before, putting the while and for loop side by side, top or bottom in this case. We have a counter, we have a condition, and we have the increment. So this is very important for loops, right? To have an effective loop, we always must have these three components, right? The counter, the counter, the condition, the terminating condition. Sorry, the terminating condition means the condition has to end at some point, and we have the incrementing. Okay. So now let's jump into practice, right? So I want you guys to take in an integer n and add up all the numbers from 1 to n. Okay, 1, 2, 3. For example, if an output number. For example, if n is 10, we want to output 55 because it's 1 plus 2 plus 3 plus 4 all the way to 55. Okay, so some hints. You can create an additional variable answer, and we use a loop to add to the answer n times. Right, so there's this new variable. We just keep adding to this new variable. Okay, so I'll give you guys about 10 minutes to do this, and then we'll go through it after. All right. Yeah. Okay, thank you. Okay, hi guys. I'll now carry on with going through the question. I hope you guys have somewhat got it. If you haven't, don't worry. I'll go through it with you guys. Okay. So yeah. Okay. So take it in integer n, right? Yeah, and I want to add all the numbers to a number, right? So I said I want to create a new variable. Let's call it answer, and since we haven't added anything, right, it's gonna be 0, right? So I'm gonna use a for loop first, okay? So for, let's say, counter, it's 1, yeah, and then counter less than equals to n, and then plus. Okay. So yeah, so from here I'll just answer counter, right? So now counter will add 1 plus 2 plus 3 plus 4, and then it'll give me the answer 55, right? Why this works is because when counter is 1, I add answer to counter, so 1, and then after this counter will be 2, right? So I add 2 to the answer, and then add 3, and then add 4 all the way until counter is 10, and then we'll get 55. Okay, so let's try running this. Please ask any questions if you guys need. My team and I will help you. 10. Oh yeah, we didn't output answer. Oops. All right, there we go. 10, 55. Yeah. So yep, this is correct because we did this. Okay. So yeah, so this is for the for loop part. Now let's go through the while loop. Okay. So similarly, we have a counter, but now it's just outside of the loop. And then while counter is less than equals to n, because we want the counter to go all the way up to n, right? All the way up to n1, all the way to 10. N is 10. Okay. So now just answer plus equals to counter, and then don't forget to increment your counter. So with the counter, we have the condition, we have the increment. Okay, so this should work as well. Okay, 10. Yes, 55. Right, so as you can see, these two work. This is the for and this is the while. Okay, so please clarify if you don't understand what's going on, because this is a very key concept if you want to learn, you want to further your knowledge on programming. Okay, so I'll give you guys maybe like a minute to copy down this if you guys need. Okay, just to clarify, this is a separate variable that we use to add our stuff, right? Add our answer to. Okay. Yeah. So in many programming questions, we usually need to create more variables to help us in our problem, right? So yeah, a bit more. Just copy this down. Okay, this is the while loop. This is the for loop. Okay, for loop, while loop. All right. You can take a screenshot too if you want. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, thank you. And that'll be all for my part. I'll be passing the time to Gabriel, who will talk about functions. Okay, thank you for your time.
Okay, hello guys. So I'm going to start now with the last topic of the day, which is functions. So let's begin. So first up, what exactly are functions? So functions, in essence, they take an input and then they make that input go through a certain process in order to produce an output. So the best way that we can understand this is if we relate it to math. So for example, we have a function. So functions in programming and in math are actually very similar. So if we have a function in math, let's say fx is equal to x plus 5. So in here, the input is actually x, and the process is adding x by 5. So the output will be produced according to the input, so what x is. So let's say if x is equal to 2, then f2 will be equals to 2 plus 5. The output is actually 2 plus 5, which is 7. So I hope that's a good enough explanation. So what a purpose of a function? So what's the function of a function? This is a small fun. So functions in programming, they're a chunk of code that can be reused. So this means that you don't need to rewrite the same code multiple times, which will be seen later on. So this functions also break down a problem into smaller chunks to make them easier to solve. And lastly, they give a clean and neater code. This is mostly because you do not need to write the same code multiple times. They actually have an additional purpose, which will be explained later on. So here is the basic syntax of function. Okay, this might look overwhelming, but let's go through this one by one. So the first thing is the return type of the function. So if we go back to the previous example, which is in math, if we have the fx is equal to x plus 5, the data type of the output is a number. So it can be an integer or a float. So in this case, we write int or float in the return type. You do not need to write the arrowhead brackets. This is just here for the purpose of explanation. So after that, you also need to write the name of the function and followed with a round bracket. And what's inside here is actually the inputs of the function. So you can have as many inputs as you want, or you can even have no inputs at all. So the official term for the inputs in programming is called arguments. So inside here, you also need to state the data types of each input. So it'll be seen later on in the example. And after this, you put the curly brackets, and inside here is the process you want to make the input go through. After that, you return the output. And to actually use the function, we need to go to int main. So notice that up until now, you have all been doing your code inside int main. So functions is actually going to be written outside of int main. So in order to use the function inside the main, you actually need to write the name of the function, then put the round bracket and input the inputs according. So we can see this in the example later on. So we have, let's say we want to have an addition function which takes in two inputs, a and b, which are both integers, so which are seen here, int a, which means a is an integer, and int b, which means b is an integer also. You notice that the output, the data type of the output is also an integer. And the name of the function is add. The process is these three lines. So int c, it initializes a variable c first, then it assigns the value of a plus b into c. After that, it returns c. So this is the whole function. And if you have to have a subtract function, you have similarly, you have two variables, a and b, which are both integers. And the data type is also an integer, the data type of the output. And the process is that you first initialize a variable c, then you assign the value a minus b to c, then you return c. So now I'll run through the example in the code column. So let's delete this. And let's write the example. Int add int a, comma, int b, int c, c is equal to a plus b, and return c. So this is from the example earlier. So if we want to use this function, you need to call it inside int main. So I'll show you what calling a function actually means. So when we use the function, you can think of it as we convert the inputs into an output. So let's say we want to store the result of the addition into a variable. Let's call it int x, and we want that x is equal to add the addition of 2 and 5, let's say. So what this does is the input is 2 and 5. So the inputs actually correspond to the order when you define it in outside the main function also. So 2 is actually A and 5 is B. So if you flip this, let's say 5, 2, 5 is now A and 2 is now B. So this will then be converted to the result of the function, which is 7. And then it will be passed on into X. So a common misconception is that some people think that return and cout is the same, but that's not true. So return actually passes on the final output of the function, while cout actually passes something to the console. So if you, let's say if you try to do, okay, I forgot this. So let's say if you try to do this, this actually does absolutely nothing. Nothing will be shown in the console. If you want to output something to the console, you actually need to do cout add 5 and 2. Or in this case, you can just cout x. So as up until now, does anyone have any questions? If you have questions, please put them in the chat. Well, my teammates will answer them for you. If not, I think I will continue. So I said earlier that functions help you makes you not need to repeat the same code multiple times. So what I mean is that in this function, we have 3 lines. So if we want to have a lot of adds, so let's say we have int x, y, z, and y is equal to add 3, 6, and z is equal to add 4, 10. Instead of writing 9 lines in order to go through this addition process for each of these variables, you can just write x equal to add 5, 2, add y is equal to add 3, 6, and so on. And it's much clean and neater. So you might argue, well, in this case, can't you just write x is equal to 5 plus 2, y is equal to 3 plus 6, and so on. Well, you're correct, but this is only like this because of the simplicity of the function we just made. So if the function gets more complicated, so for example, if we want to check even number, okay, so why don't we try to create a function that checks an even number? So the output of this would be Boolean, so true or false, and the name is check even. And we want to check integer, which we call number. And the process is, so from Ika's part just now, you learned how to check if a number is even or not. So if num mod 2 is equal to 0, we return true, else return false. So yeah, so this is a function that checks if the number is even or not. So let's check if this works. So cout check even 6, and if we run this, the output should be a 1 and 0. 1 representing true and 0 representing false. And yeah, so the output is 1 and 0. So this is a slightly more complicated function than add. And if you if you want to check multiple numbers if they're even, it's much easier to use check even rather than writing this code multiple times. Of course, there's maybe a smart way to check if a number is even in one line. But if we add the complicatedness of the complexity of the function even more, like when you work in an industry, you would have a very complicated function, and you don't want to write it multiple times, write the same code multiple times. And another reason why function is useful, which I mentioned, I'll explain now, is that let's say you're working with multiple people at once on the same project, and they're assigned to do a certain part of the project while you do the rest. So functions make it easier to split the work, because when you have a function, if someone wants to use a function, for example, and they know what it's supposed to do, they actually don't need to know how the function works in order for them to use it. So let's say if we have the check even function, and a person knows that this check even checks if a number is even or not. And if the number is even, it will return true, else it will return false. So they don't need to know how exactly the function checks if the number is even. All they need to know is that it returns true when the number is even and false when the number is odd. So yeah, so this makes working together with other people easier, and so on. So up until now, does anyone have any questions? If not, as I said earlier, please pass the question to the Zoom chat where my friends will answer, where my teammates will answer. So if there are no questions, I will proceed to the practice. So the practice is this. So I want you guys to create a function which takes in two one-digit numbers and combines them into one two-digit number. So for example, we have 1 and 5. We combine it to 15. So note that the input must be integers, and the output must also be an integer. Of course, there's an easy way to do it using chars, but I want you to do this in integer. So I want you then to return that two-digit number. So also, if the arguments are not one-digit numbers, you should return 0 instead. So to make this to make your life easier, I'll try to give you a template. So int check int combine two-digit, and we have two int a int b, and we want to somehow combine this into 2 digits, and we else returns no, first we check if this is check if A and B are single digits. If they are not, return 0. Then after this, I want to return 2-digit number. So something like this. So I'll give you guys maybe 5 to 8 minutes to do this. Okay, guys, based on my teammates' inputs, I believe that I should start giving the answers now. So the task is that you're supposed to combine 2 single-digit numbers into a single 2-digit number, and you should return 0 if they are not single-digit numbers. So first question is, how do you check if something is a 2-digit number? So that's actually quite simple. You can use an if statement. So if A is more than equals is less than 10. Okay, if A is less than 10. So let's just assume that we're not dealing with negative numbers here. If A is less than 10, or B is less than 10, we return 0. So if A is less than 10, and since A and B are integers, they're obviously either 0, 1, 2, 3, 4, 6, 5, 6. Oh, wait, sorry. If A is more than equals to 10, or B is more than equals to 10. So if A is more than equals 10, or B is more than equals to 10, they're obviously not single digit because they're at least 2 digits. So 10 and above are all 2-digit numbers, which is why they are not single digit. And which is also why we should return 0. So when you return in the function ends completely. So anything after that will be ignored in the function. So whatever I type here, blah, 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 it will be ignored once the function actually returns something. So let's continue on. So next we should return the actual answer. So let's initialize an answer variable first, and the answer should actually be just 10 times A plus B. So the reason why this works is because when we have a number, so when we have a number, a 2-digit number, for example, and let's say 57. So 57 is actually 50 plus 7, which is also 5 times 10 plus 7. So this is actually how a decimal number works. In the 10-digit, in a base 10 number system, the first digit of the 2-digit number is actually just a digit times 10, and then you add it to the second digit. So ans is equal to this, and you return ans. So this should work. So if we see out combine 2-digit 1 and 7, this should return 17. And we add a new line here. Combine 2-digit, and now we're going to check if what will happen if we type a 2-digit number. So 10 and 5, this should return a 0. And see out color. And another normal case, 2-digit 9 and 9. So the expected output is 17, 0, and 99. Okay, so expected. Okay, so I missed a semicolon here. So I'll try it again. Okay, so this function works. So does anybody have a question? Same as before, if anybody has any question, I'd like you to pass the question to the Zoom, where my friends will be more than happy to answer. So let's go back. So this is actually the end of the workshop, but we'll give you a small gift. So we have an ultimate practice for you to do. We won't actually go through it. Instead, we will give you the answer, like the actual code of the answer, to you after the workshop. So if you're interested, you can look at this ultimate practice. So the ultimate practice is you make a function that takes in an integer n, and using a for loop, you add each iteration from 1 to n while processing these following conditions. If the number is a multiple of 3, you multiply it by 2. And if the number is a multiple of 2, you add by 3. And if both, minus 5, if neither, add 10. So I know you're probably a bit confused of what this means, so I'll illustrate it with an example. So for example, if n is equal to 10, we output 1 plus 10, and then you added 2 plus 3, and then you add 3 times 2. So the reason why this happened is because for 1 is actually neither a multiple of 3 nor it is a multiple of 2. That is why you add it by 10. And for 3, it is actually a multiple of 2, which is why you add it by 3. And for 3 is a multiple of 3, which is why you multiply it by 2. 4 is a multiple of 2, which is why you add it by 3. 5 is neither, which is why you add it by 10. 6 is both a multiple of 2 and a multiple of 3, so you minus 5, and so on. So then you should output this answer. So this is equals to 104. So does anyone have any question for the ultimate practice? If not, I will conclude this workshop. What? Okay, so this is technically the end of the workshop for the programming with C+ for beginners, but please stay in the call for a while until the building blocks debrief you all. We will send the answers of the ultimate practice after the workshop, so please look out for that. So I will now pass on the time to Building Blocks, which is going to debrief all of you. This is the end of the workshop. Thank you, guys.